Hey everyone, welcome to the Explainer. Consider this your absolute ultimate visual cheat sheet for crushing your upcoming geography exam on Earth's resources. I am so excited to guide you through this material today. Whether you're prepping for a massive test or you just really want to understand the fundamental building blocks that literally power our modern world, you are in exactly the right place. We're going to strip away all the textbook clutter and build a rock-solid understanding of everything from raw minerals all the way to the future of our energy grid. Let's dive right in.
Here is the game plan for today. 1. Ferrous and non-ferrous minerals. 2. Non-metallic and rock minerals. 3. Conventional energy sources. 4. Renewable energy alternatives. And finally, 5. Essential conservation strategies.
All right, starting things off with Section 1, ferrous and non-ferrous minerals. Lock this stat into your brain right now for the test. An overwhelming 3/4 of India's total metallic mineral production comes strictly from ferrous minerals. 75%. It's crazy, but it perfectly illustrates our absolute reliance on iron-based materials. I mean, these ferrous minerals are the complete foundation for all metallurgical industries. And India is actually incredibly lucky here. We possess massive, rich reserves of iron ore, deeply concentrated in major belts like Odisha-Jharkhand and the Durg-Bastar-Chandrapur belt. But here's the catch. Not all iron ore is created equal.
If you see a multiple-choice question on iron ore, you've got to know this exact difference. Magnetite is your absolute top-tier VIP quality ore. It boasts up to a 70% iron content and is famous for its super strong magnetic properties. Hematite, on the other hand, is your everyday industrial workhorse. Now, it does have a slightly lower iron content, around 50 to 60%, but it is by far the most widely used iron ore in the entire industrial sector. So, magnetite for quality, hematite for quantity and industrial utility. Don't mix those up.
Now, geography is all about the map, right? So let's pinpoint exactly where we find our non-ferrous materials. Take copper, for instance. It's highly malleable, ductile, and an incredible conductor, making it absolutely vital for all our electronics. You'll find it heavily mined in Balaghat, Khetri, and Singhbhum. Then we have bauxite, which is formed from decomposed rocks rich in aluminum silicates. It's the essential primary ore for aluminum, and you'll find that largely clustered in the Amarkantak Plateau, the Michael Hills, and the Bilaspur-Katni Plateau region.
Okay, before we move off metals entirely, I love this fast fact to help anchor your memory. It takes exactly 10 kilograms of manganese to manufacture just 1 single ton of steel. 10 kilos to 1 ton. Manganese is basically the magical secret ingredient for steel and ferromanganese alloys, though you'll also see it pop up in everyday items like bleaching powder, insecticides, and even paints. Just keep that ratio in your head.
Moving right along to Section 2, non-metallic and rock minerals.
Ever wonder what keeps complex electronics from just shorting out? It's mica. Found largely along the northern edge of the Chota-Nagpur Plateau, mica is the absolute champion of the electrical and electronic industries. And here's exactly why. It has high dielectric strength, low power loss, excellent insulating ability, and an immense resistance to high voltage. When a test question asks why mica is totally indispensable for electronics, boom, use that exact terminology.
Next up is a rock mineral you literally see the results of every single day. Think about the concrete walls of your school or the very foundation of your house. They rely entirely on limestone. Composed mainly of calcium carbonate, it is the fundamental raw material for the cement industry. But it gets better. Limestone is also absolutely essential for smelting iron ore in blast furnaces. So it's really the silent, unseen partner to that iron ore we discussed earlier.
Let's power up with Section 3, conventional energy sources.
Coal is without a doubt our most abundant fossil fuel in India, sitting in massive fields like Jharia, Raniganj, and Bokaro. But you have to be able to rank these 3 distinct types by their quality, their moisture content, and formation pressure. At the bottom we have lignite. It's a low-grade brown coal with really high moisture. Sitting in the middle is bituminous, deeply buried and formed under much higher temperatures, making it super popular for commercial use. And at the absolute top is anthracite, the highest quality, hardest coal available. Now think about oil. Petroleum, extracted from regions like Mumbai High, Gujarat, and Assam, isn't just fuel to put in your car. It acts as a vital, nodal industry. What does that actually mean? It means petroleum refineries serve as the central hub, the anchor, that supports massive peripheral sectors like synthetic textiles, fertilizers, and a ton of different chemical industries. It is literally an entire economic ecosystem inside a barrel.
And we definitely can't forget natural gas, often found in the Krishna-Godavari Basin, which acts as a cleaner, more environment-friendly companion to petroleum.
For your electricity questions, make sure you grasp this fundamental difference. We generate grid electricity primarily in two ways. Hydroelectric projects, like the massive Bakra Nangal, use the sheer force of flowing water to drive turbines. This is completely renewable. On the flip side, thermal power is generated by burning the fossil fuels we just talked about, coal, petroleum, and natural gas, and that is strictly non-renewable.
Which brings us to a really daunting question, and honestly, a highly likely long-form essay topic on your upcoming finals. We are relying incredibly heavily on finite resources. So what is the backup plan when the thermal plants eventually run out of fuel? That naturally brings us to Section 4, Renewable Energy Alternatives. Again, geography is all about location, location, location. Memorize these spots. If you're asked about wind energy, point straight to the massive cluster down in Tamil Nadu, stretching from Nagercoil to Madurai. For tidal energy, which uses the natural rise and fall of ocean tides, look to the Gulf of Khambhat, the Gulf of Kutch in Gujarat, and the Sundarbans. And for geothermal energy, tapping into the sheer heat from the Earth's interior, you need to know the Parvati Valley in Himachal Pradesh and the Puga Valley in Ladakh.
So, the trick here is not just knowing where they are, but exactly how they work. Make sure you can briefly explain these specific mechanisms. Nuclear or atomic energy is produced by fundamentally altering the atomic structure of elements like uranium and thorium. Solar energy uses photovoltaic cells to magically convert sunlight directly into electricity. And biogas is this fantastic rural solution produced from the decomposition of organic waste and cattle dung. It's a double win because it not only provides clean energy, but it also yields high-quality manure for agriculture.
Finally, we've made it to Section 5, Essential Conservation Strategies.
You really have to understand the true stakes here. Minerals are strictly non-renewable resources that take thousands, if not millions of years to form. Our current rate of rapid, continuous extraction leads directly to the depletion of these reserves. We are literally consuming, in a matter of decades, what the Earth took millennia to create. This is exactly why planned, judicious, and sustainable utilization isn't just some corporate buzzword. It's a literal survival strategy for the planet.
If you get a classic free response question asking how we can actually save our energy resources across domestic and industrial sectors, hit them with these exact actionable measures. It starts right at the individual level, preferring public transport over private vehicles to save on petroleum, simply turning off electricity when it's not required, upgrading to energy-efficient appliances, and on a macro level, relentlessly promoting and adopting the renewable energy sources we just went over. Because honestly, energy saved is quite literally energy produced.
So as you head into your test, try to think beyond just memorizing the textbook. How do these crucial conservation strategies apply directly to the real world that we are building right now? You now have the ultimate cheat sheet of what our resources are and exactly how fragile our supply is. The real test is what your generation is going to do with this knowledge. Best of luck on your exams. Keep reviewing these core concepts, and I will catch you in the next explainer.